Okay, so let me just say this about we're going to cover section 4.6 today, which is on modeling exponential functions. Okay, now here's what I want to say about this section. They give you a lot of formulas. I don't like to remember very many formulas, and I've already given you the formula that you need, which is basically A equals PERT. Okay? You all remember that. That's the continuous compounding formula. Okay? It works the same way. They basically change it to be sometimes they use N's and M's, and it's just dumb. But basically, they've got this formula here, M of T equals M sub 0 e to the, sometimes they put a KT, RT, whatever. It's the same thing, okay? And rather than having to remember all these different formulas, I'm just going to say, just remember that one formula, and it's, because that's plus A equals PERT, that, you remember, it's like shampoo or something, okay? All right, so let's just do a few problems here. So under ideal circumstances, bacteria colony doubles every 3 hours. You start with 1,000 bacteria. So, A, find a model for bacteria growth after T hours. Okay? Maybe we could make this even practical and say, pretend it's not bacteria, it's a coronavirus. Okay? All right, so what do you think? Zach, you got any ideas how you do this one?
You start with 1,000 bacteria.
Okay, so 1,000 would be our what? P. In this formula.
Our P.
You can think of that as your principal, okay? So we've got 1,000 bacteria.
And then the rate is doubles to
E. Well, so we don't know the rate yet. Okay. But we know that it doubles every 3 hours. So if my time is 3 hours, how much will I have? If it doubles every 3 hours, how much am I going to have? I start with 1,000.
2,000.
I'm going to have 2,000. Okay? So what we can do is we can figure out what the rate is. Okay? So how would you solve for the rate in this case?
Would we first divide 1,000?
Divide by 1,000. Divide by 1,000. We're left with 2 equals
2 equals
E
R.
to the 3R. Okay?
Then would we take the ln of both
Natural log of both sides. So the ln of 2 equals 3R. And then divide by 3. So your rate is going to be the ln of 2 over 3, which you can plug into your calculator. Now, let me just say this. If you want to plug it into your calculator, and you're doing more parts of this problem, use all of the digits your calculator gives you, because if you round, you're going to end up with a rounding error. Okay? So use all the digits. Or you can just leave this as your rate. Okay? So now that we know this is our rate, okay, we're going to plug it into here, and we need to make this a function of time. So A of t equals what? So we're going to create our model. So go to Joey.
My calculator says 0.23.
Oh, okay. 0.23.
104906.
Okay, so you could use that, or you can just use this, and I'm totally fine with that. Okay, so it says find a model for the bacteria. Well, do you got any good equations that will help us with that? Yeah, this would be a really good.
Yeah.
So A of T equals what? What's P?
1,000.
Started with 1,000 bacteria. So principal E to the what?
The R would be
R would be the ln of 2 over 3, or you could type that number in, times T. Okay? Does that make sense? There's your model. Okay? Let's go with part B. Part B says, am I off camera? Boy, this is really out of focus. I apologize, but it's just a crappy camera, and I forgot my good camera today, so I'll try to remember to bring that. All right, part B says, how many bacteria in 15 hours? So how would you do that one, Jeffrey?
So you plug in 15 for T,
Take for T in our new formula that we just created. Okay, so tell me what to write.
A of T,
A of 15
oh,
equals
equals 1,000
1,000
E,
E
natural log of 2,
natural log of 2 over 3
times that.
times 15. 3 goes into 15 5 times. I'll save you a little bit of math. And if you plug it into your calculator, hopefully, correctly, you should get approximately 32,000. Okay? Yeah, I'm looking at the right one. All right, then part C says, when will it reach 100,000? So, Maddie, it must be your turn. A of T? Don't we know what A of T is? It's how much? No, P is 1,000. What'd you say? Not speaking very loud. We're using this equation, right? And what's A of T? It's 1? What'd you say? Is it 1? What does A stand for? In this formula, what does A stand for? Anybody know? Throw it to anybody. Eunice knows. Yeah, the total amount or what you accumulated, okay? So the total amount is 100,000, there we go. Equals P, what's your P? what's the principle we started with?
1,000.
We started with 1,000 bacteria, e to the natural log of 2 over 3 times t. And your t is, well, that's what we're solving for, right? Okay, so the 1,000 takes out 3 of those zeros. And then if I take, then, so what do I do? Natural log of both sides. Okay, so that's going to wipe out that. The ln of 100 equals the ln of 2 over 3 times t. How do we solve for t? Divide by ln of 2 and multiply by 3, so those will cancel, right? And then I got a 3 and an ln of 2. Okay, so your time equals 3 times the ln of 100 all over the ln of 2. And when we plug that in our calculators, we should get approximately 19.93 hours. Okay? Sound good? Okay. All right, let's do this one. All right. A breed of rabbit was introduced 8 months ago. Current population is 41,000 rabbits and doubles every 3 months. A find initial rabbit population. Okay. So, James, what do you think would be a good, useful equation that might help you figure this out? A equals PERT, right? So A equals PERT. Okay. All right, so we've got 41,000 rabbits now, right? Is that going to be your A or your P? Will be the P. So if we got 41,000 now, and it doubles every 3 months, how much are we going to have in 3 months? 82,000. All right. E, do we know the rate? No, we don't know the rate, but we know that the time is 3 months. In 3 months, we're going to go from 41,000 to 82,000. Okay? So how do we solve that for the rate?
Divide by 41,000.
Divided by 41,000. So 82,000 divided by 41,000 is 2 equals e to the 3r.
A natural log.
Take the natural log. That comes out front. So the ln of 2 equals 3r. Oh, this feels like the same freaking r I had last time. Is it different? No, it's exactly the same. That's right. Okay. All right. So R equals the ln of 2 over 3. We want to know the initial population of the rabbits. Okay? So it doubles every 3 months, and it was introduced 8 months ago. Okay? So we need to think about that as far as time. So if we start with 41,000 now, and we want to figure out what P is, and E is E, and your rate is this, right? ln of 2 over 3. And your time, if it doubles every 3 months, let's think about this for a minute. So that's all, that's not quite. So we need to figure out what our time is.
Isn't it 8?
I guess it's just 8 months, right? Yeah, it's 8. Okay? All right, so now how do we solve for P? Just divide by that, right? Divide by that, so it's 41,000 divided by E to the ln of 2 over 3 times 8. What does that come up with? Hopefully a number less than 41,000. Hopefully, if we did it right, we should get n equals about 645. Is that what you guys get? Did you get it, Hallie? Neither. Let me see what this is what I would do on Excel. Pull up Excel, the greatest calculator of all time. So equals 41,000 divided by E XP to the ln of 2. We're going to take that number, we're going to divide by 3 and multiply by 8. Let me make sure I'm doing this right. I'm going to put in that with 7 parentheses here. False. Oh, that's because I forgot to put a times. Oh, that didn't work. 41,000, here we'll do it this way. The ln equals the ln of 2. We're going to take that number, we're going to divide it by 3. We're going to take that number, we're going to multiply it by 8. Oh, except for we're not going forward in time, we're going backwards in time. My rate needs to be negative, right? Is it a negative 8? Equals that times negative 8. There we go. And then if I do exp to that equals that times 41,000. Why am I off a decimal? I'm off a decimal. What did I do wrong? ln of 2 divided by 3, multiplying that by negative 8, exp times 41,000. Why am I off a decimal? It should be a negative because we're going back in time. What's that?
-8, is that? So
Yeah, we're going 8 months back. Why am I off a decimal? Let's see here. We used a different formula. Mine should work. Oh, they've got 40, oh, that's why. I put 41,000 and they put 4,100, that's why. So I'm correct. My answer's correct. So 6457. That's why. I put an extra zero on there. So we would have started out with 6,457. So mine was correct. Okay. All right, does that make sense? All right, the last one that I want to do, oh, I should have done one on the decay. But as you can see, you can have a negative rate, so this works for radioactive decay. But I want to spend a little bit of time with this last one here, which is Newton's law of cooling, because this one's a little funkier. All righty. Newton's law of cooling. Okay, so it's basically T of T equals T sub S plus V0 times e to the minus KT. Now, do you see here, even though they're using a bunch of different letters, this is basically PERT. Do you see that? P-E-D-R-T. It's the same thing, okay? Now, a couple things that we need to know. This T of T is the temperature at time T. T sub S is the surrounding temperature. D sub 0 is the difference between the object and the surroundings. And K equals your rate. Okay? So let's do a quick example here. A cup of coffee is 200 degrees Fahrenheit. And the first question I have to say is, why are you buying coffee that's that hot? It will cause third-degree burns. You heard about the woman who burned herself?
Yes.
You should see the pictures of her burns. They are nasty, like really gross, okay? She was trying to sue McDonald's to say, quit heating your coffee to 200 degrees Fahrenheit because it will cause damage. It was horrible. Anyway, so a cup of coffee at 200 degrees is 200 degrees Fahrenheit, is placed in a room at 70 degrees Fahrenheit. After 10 minutes, the coffee is still too hot to drink, 150 degrees Fahrenheit. Okay? So find a function at time t. Okay? So, Cameron, how would you do that? Harvard. If we're using this nice little formula here.
Right.
So T of T,
So would it be 150 is equal to
Okay, so the current temperature, 150 degrees equals
Yeah, and then surrounding temperature, so 70 degrees
70 degrees plus
plus difference between, what does that say, the DO? Difference between what?
difference between the object, in this case, the coffee, and the surroundings.
Okay.
So the coffee is 200, right?
Yeah.
And it's placed at 70
50,
degrees. So
so
this
plus-
becomes
Oh, difference between surrounding?
Yeah,
Okay,
200
100, 130.
130
And
times
then
E.
to the negative,
K, or R, you could use rate,
right, which
times your time,
which is 10 minutes.
10 minutes. Okay? All right, so how would we solve that for K?
Sorry, are you asking me?
Yeah.
To solve for K, so first we'd minus 70 from both sides.
Okay, 80 equals 130 e to the minus 10K.
Then we divide by 130.
So 8/13 equals e to the minus 10K.
And then you put them both to the natural log.
Natural log, okay? So the natural log of 8/13
Is equal to negative 10K.
equals
And
negative
then you
10K.
divide by
Divided by
negative.
negative 10. K equals the ln of 8/13 over negative 10, which, if you plug it in your calculator, equals 0.04855. Okay? So now let's plug it back into this formula here. So we got t as a function of t equals, and we'll go ahead and use this number here. Temperature of your surroundings is
70 degrees.
70 degrees plus the difference,
Which is 130.
130
The E
E
to the negative 0.04855.
5 times any time t. Okay?
Do you want that answer, or would you rather, oh, you're just looking for a function?
If you wanna stick this in here instead of that number, that's fine. Okay? Now, just a reminder, it's test week this week. Okay? Otherwise, you're gonna have, so we don't wanna add any more logarithms, do we? Okay, so we're gonna cover, so 4.6 was today, quiz tomorrow's 4.6. Tomorrow we'll do 5.1, which is not logarithms, so you should like it. And then Wednesday's our review, Thursday will be our test right here. And so see y'all tomorrow.